Hi everyone, this is Dr. Delosier, and I'm going to do a walkthrough of the EC312 6-week midterm from spring 2024. So moving on to the first question here, we're looking at a piece of C code with a loop and some arrays, and we got to answer some questions about it. So I'm going to do parts A to C here, and then we'll move on to the permissions questions after that. So starting off, what is the total number of bytes that will be allocated for the variables in this program? So our variables are always at the start of our C program, right? And so we want to find int main, and then the lines up until we don't see like an int or a char or a float or something at the beginning of the line. That's going to be all of our variables. After that, we start executing code like changing the values of the array, doing for loops, things like that. So we're really just looking for these lines that start with, int or char or something like that. And so here we've got int runs per inning 9. And importantly, because that gives the size of the array, that means we have 9 ints there. So that array is size 9, and it's type int. Likewise here, we have another 9 ints. And then here we have int I, just a single one, and that is 1 int. So in total, we've got 9 plus 9 plus 1 ints, and ints are 4 bytes per int, and so this should be 19 times 4 that we're doing, and that should give us 76 bytes total. Okay, so again, finding the variables in the code, and then summing up using those rules for how much we have in terms of byte usage. Part B, what will be the value of score 2 after the for loop completes? So normally I would sort of list out everything the loop is doing and kind of walk through it. In this particular case, because each iteration updates an element of the array based on this index I, right? And I is changing starting at 1 every time we go through the loop. And it's also based off of sort of, it's using I in the entire line of code here. So really every iteration of the loop is just changing one of the elements of that array. So understanding that can let you shortcut this a little bit. And what we would want to understand then is, okay, what's happening to score 2? And so the only way score 2 is getting modified is if it's on the left-hand side of an assignment. So score 2 is going to get modified at this point in the code. Now we may want to check just to make sure, like, does the changes that happened earlier in that loop affect that? And they actually do. So we need to see what happens to score 1 because score 1 is going to be part of this statement. So our score 2 update is going to look like this. Score 2 equals score of 2 minus 1, which is going to be 1, plus runs per inning at 2. And so here we're just basically substituting into this line of code. Everywhere I see I'm replacing it with 2 since that's what we're going to update. So that's what's going to happen during that iteration. But importantly here, right, this score 2 plus 1 is going to be score of 1. So we need to know what happened to score of 1 in the previous iteration of the loop in order to understand what happens with this program. So we're going to have score 1 minus 1 is going to be 0, plus runs per inning at 1 here. And so that's what's going to update. That's what we're going to update score 1 to. So let's go ahead and see what happens there. So score at 0 is runs per inning at 0. And so that's equal to 1. So score at 0 is 1. That's what I'm substituting here. Plus runs per inning at 1. Right? And keep in mind, this is index 0, index 1, index 2. Right? We start counting from 0 in arrays. So runs per inning at 1 is 0, which means score at 1 is just 1. So then when we substitute here, score at 1, we're going to have that's equal to 1 plus runs per inning at 2, which is 2. And so score at 2 is going to be equal to 3. So that was maybe a little roundabout way. It might be easier to sort of go, just walk through the loop through each step until you know what score 2 is, and understand that because it's only modifying I each time, once it gets to 3, nothing is happening to score at 2 anymore. Okay, on to part C. If runs per inning 0 is stored at address BFFF500, what address will runs per inning 5 be stored at? So this is trying to understand how arrays are stored in memory. So if we start at OXBFFF500, and that is a 4-byte integer for, I'm just going to say RPI at 0, just to make it easier to write, but that's runs per inning at 0 is what I'm referencing. If that takes up 4 bytes, then RPI at 1 is going to be at OXBFFFF504, because we have to go 4 bytes from where our initial integer was, right? It takes up 4 bytes of space, so the next thing that we can fit is 4 bytes later in memory. And then if we continue this down, we eventually get to where RPI at 5 would be in memory. We can shortcut this a little bit by just saying that, before RPI at 5, we need to store 0, 1, 2, 3, 4. That's 5 different integers. And so 5 times 4 bytes is 20 bytes. So we're going to go 20 new spaces down in memory. Keep in mind that this number is decimal. And if we add OXBFFF500 plus something, that number needs to be in hex. So we need to go 20 dec to hex is going to be, instead of 20, it's 1 for 16 and then 4. So OX14. So we're going to add OX14 to 500, and we end up with BFFFF514 is our final answer for that one. You could also just sort of continue this diagram down until you get to RPI 5 and you would get the same answer, right? Just add 4 each time. That might be a little bit easier, but regardless, show your work how you're getting that answer.